I'd like to work through a couple of more of these normal distribution, percentile rank, z-score questions with you. I know that these can be a bit challenging, and it's really key that everyone understand how to use these tables, because we will be using these tables or similar tables going forward for the rest of the semester. So let's take a look at this even-numbered problem at the which is in Chapter 5, Problem 4. I'm going to start out with Part B, but let's read the problem first. A criminologist developed a test to measure recidivism where a low score indicates a lower probability of repeating the undesirable behavior. The test is normed so that it has a mean of 140 and a standard deviation of 40. So let's skip A for the time being, and we'll start with B. Simple question, what's the z-score associated with a test score of 200? So the formula we need to use is our z-score formula. The z-score formula is as follows, x minus x bar over s. Remember, every score has a corresponding z-score. Doesn't matter what the score is, any score in a distribution has a corresponding z-score that you can figure out, that you can compute as long as you know the mean and the standard deviation for the distribution. And in this case, we do. X bar we have equal to 140. Standard deviation we have equal to 40. So at this point, it's just a question of plugging, and the x value, I should say, that we're asking about is 200. So let's just plug in some figures and compute this very simple problem. We're going to have 200 minus 140, all divided by 40. And that is going to equal 60 over 40, and 60 over 40 equals 1.5. So the z-value associated with a raw score of 200 is 1.5. Okay, now that you know how to calculate the z-score, we can take a step back and take a look at problem A. Let's look at that one. What do we have going here? What is the percentile rank of a score of 172? All right, again, let's write down what we know. X bar equals 140, X equals 80, okay? And, oops, no, it doesn't really matter how I write it. S equals 40. So, we need to find out the percentile rank of a score of 172. We always want to start these problems by drawing out a normal distribution so we know what it is we're looking for. And it can be as poorly drawn as the one that I've drawn out over here. Our mean is 140, and that corresponds to a z-score of 0. And we're looking for the percentile rank of a score of 172. So we're looking, of course, the percentile is the score such that that percentage of scores falls below the given score. So we want to find out the percentile rank. Let me just do that in red, actually. We want to find out the area under the curve to the left of a raw score of 172. So what do we need to do? Well, the first thing we need to do is we can't use these raw scores because the table doesn't give us the answer that we need. What we have to do is we have to convert this raw score into a z-score and then just look up the value in the table. So let's take a look at that. Let's convert this score of 172 again to a z-score. So the z-score formula, z equals x minus x bar over standard deviation. In this case, we have 172 minus 140. Remember, we want a z-score associated with 172 over 40. And if you do that little bit of arithmetic, you're going to find out that that's going to give us 32 over 40. And that's equivalent, that's a z-score value of 0.8. 0.8. Now we can go to our z-score table and find out the area under the curve. So let me pull up a portion of the table that we want to use. I've got that right over here, and let's take a look. How do we use the table? That's the tricky part. Well, the thing to remember, column A is going to give us the z-score. That's the score we need to look up. Column B gives us the area between the mean of the z-distribution, which is always 0, and the z-value that we're interested in. So if I draw that out, I'll draw it up here at the top. That's going to give us, if that's the mean over there, z-value of 0, then column B is going to give us this area in here between the mean and the z-score we're looking for, which in this case is 0.8, but we'll get to that in a minute. Column C rather, is going to give us something a bit different. Column C is going to give us the area between a given z-score and the tail of the distribution out here, that area in there. Okay? So for this problem, we're interested in the percentile value associated with 172, and that's this area that I've shaded in red with these red arrows over here. So let's look down to our z-score. Our z-score of 0.8 is what we're looking for, and that's right over here. Right? So we want the area between the mean and this z-score, and that is equal to 0.2881. Now, here's where things get just a little bit more complicated. These tables are set up to give us the area, again, between the mean and a z-score. In this problem, we're interested in the percentile value. So that's going to include, certainly, this area in here in green. That's the area that we're getting off of the z-table. But it's also going to include this area that I'm shading in here in yellow. Because again, we're interested in the percentile value from a score of 0 to a score all the way up to 172. Now, we know that the normal distribution is symmetrical and that it's divided into 2 at the point of the mean. If it's symmetrical, the total area under the distribution is equal to 1. That's by definition. And if we take 1 and divide it into 2 parts, each part is going to be 0.5, obviously. So we have to take this area here of 0.5, and we needed to add it to the area in the table that we're getting, 0.2281. Oops, I did that wrong, sorry, 0.881. Just fill that in again, didn't mean to erase it. And that's going to give us 0.5 plus 0.2881, which equals 0.7881. So we can say that 78%, 79%, say, close enough, 78 or 79% of the folks who took this recidivism inventory, this recidivism survey, are going to score 172 or below. That's what a percentile rank actually is. Let's move on now to part C. Let me draw this out for you first. That's always the way to start, especially if we're not sure where we're at. In part C, we're looking for something a little bit different. Again, we draw that out as usual. And in part C, we're looking for scores between 100 and 160. Our mean is 140, and of course that corresponds to a z-value of 0. And we're looking for scores between 100, so we know that'll be to the left of 140, and 160. We know that'll be to the right. So what we're looking for here then is this area in here. We're looking here for this area in here. So we need two z values, right? We need the z-value associated with 140. I'm sorry, with 160. And we need the z-value associated with 100. So we'll solve for those right away. We know that z equals x minus x bar over s. So in this case, for the first one, we're going to have 100 minus 140 divided by 40, our standard deviation. And that is going to give us what? That is going to give us negative 40 over 40, or z-value equal to negative 1, negative 1. So let me just jot that in there, negative 1. And now let's find out our second z-value for 160. I'm going to just call it z for a score of 100. And now let's figure out the z-value for a score of 160. And there we've got 160 minus 140 divided by 40. So z 160 equals 160 equals 20. That should be a 6. 160. That's going to be equal to 20 over 40 for a z-value equal to 0.5. So now what we need to learn is we need to learn this area in here, and that's associated with this z-value, and we need this area in here because we want to know the percentage that's scored between these two scores of 140 and 160. All right, so let's go out and take a look at our table. So we look down our z-values over here, and let's go down, let's take a look at z-value of 0.5 over there is equal to probability or the percentile, whatever you like, percentage or whatever you like, is 0.1915. And now we'll go take a look at our z-value for negative 1. I've copied the table over from the text. You see that over here. Again, we'll just label that's column Z. And we're looking for a z-value associated with negative 1. Now you'll notice that in our table we only have positive values. We don't have negative values here. But it really doesn't matter because remember, the z-distribution is symmetrical, so it doesn't matter which side of the distribution we're on, the value would be the same. You could do this with a negative value, but it wouldn't. You could set up a table that had negatives, but that would be superfluous. No need to do that. We can use this value over here. So again, we look down and we find that value of 1 there is 0.3413. We'll just write that probability in over here. That is 0.3413. 0.34113. All right. So all we have to do is just add these two values up to get the total area here, again, between a raw score of 100 and a raw score of 160. So we add those up. About 53% of everyone taking this test will score between 100 and 160. Okay? So that's how you solve that kind of a problem. We have a couple more to do now. What's the proportion of respondents who score above 190? How do we figure that one out? Let me erase what I have and we'll get right into it. Okay, so now I've erased everything we've done so far, and let's tackle problem D. What proportion of respondents should score above 190? Again, let's draw out what's going on here. Well, let's first record everything that we know. X bar, again, equals 140. Our standard deviation is 40. And we want to know the number of people, the proportion of people who score above 190. So x is going to equal 190. In this case, again, critical, draw out the problem, and we're looking for, this time, the folks that scored out in this area above a raw score of 190. And what's the corresponding z-score? Well, we have to compute that. So the first thing we want to do is we want to go to compute that z-score, as I said. Z equals, as always, x minus x bar over standard deviation. In this case, z equals 190 minus 140 over 40. And that is going to be equal to, I'll just do that all for you in one step, save us a little bit of time and screen real estate. Basically 50 over 40 is 1.25. All right, so now we need to look for a z-value corresponding with 1.25. Let me paste in a table. There we go. And we'll look down column A where our z-scores are, and we have a z-score of 125 over here, 1.25 over here. Now, remember how the table is set up. This section of the table over here is going to give us values in the tail of the distribution that I've colored in there. That's what we're interested in here, right? So we need that number over there. The proportion of people, or the percentage of people that score above 190 is equal to 1056, or about 10%, well, about 11%. So 11% of the people who take this test will score above 190. All right, let's move on to the last one, E. And let me just erase everything here and get set up for that. Okay, we've cleared the decks, and let's tackle E now. E is different than all of the other problems that we've looked at so far. The other problems, we were given a z-score, and we wanted to find out a percentile, or a percentage, or a proportion. In problem E, we're given a percentile or proportion, and we need to find the corresponding recidivism score. Let's see if we can figure out how best to solve this. Let's write the z formula out again. Oops, that's not what I meant to do. Let's put an S. Okay, so what do we have? We know that we got something that looks like this. X minus 140, our mean, divided by 40, our standard deviation, is going to give us a z-score, right? What's the question asking? What is the corresponding recidivism score at the 67th percentile? What's the corresponding recidivism score at the 67th percentile? Well, let's take a look. How might we solve this? Again, start with a drawing, start with a sketch. In this problem, we're given a percentile value. That's the area I've just shaded in here in yellow. And from that, we're being asked to determine the z-value that corresponds with this boundary. So what we're going to need to do is we're going to need to get this z-score. We're going to need to get that z-score based on this 67%. Once we get that z-score, we rearrange the equation to compute the raw score associated with it. All right, so how do we get that z-score? Well, we know that our tables are set up to show us just the area from the mean to a given z-score. Yet we also need to include this whole area over here as well, which represents 50% of the distribution. So what we have to do is we have to take this 67%, just because of the way our tables are set up, just because the tables are only going to show us the yellow highlighted area. That's the only reason we need to do this. So we're going to take 67% and subtract out this 50%. We're going to subtract out the whole green area here. We're going to subtract out that green area. So we are looking for the z-score that corresponds with 17% or 0.17. All right. Just got to shift this over a tiny bit. Let's see what we're doing here. And I happen to have the correct table here. We'll paste it in. Okay. So what z-score corresponds with 17%? Well, now we're going to look in column B. We're going to look in column B for the z-score associated with 17%. So we read down, and you'll see that there's our 17% area, corresponds with a z-score of 0.44. So z equals 0.44. At that point, the problem becomes a simple one. All we have to do is a little bit of algebra. So we've got 0.44 equals x, we don't know the raw score yet, minus 140 divided by 40. So how do we solve this? Well, we multiply both sides of this equation by 40. 40 times 0.44. And then we need to get rid of this negative 140. So we add 140 to both sides of the equation. And when we're going to solve this, we are going to get 157.6. So the raw score corresponding to the 67th percentile is 157.6. That's the correct answer. I want to show you one other thing here. If I can find it. Just give me a minute. Here it is. Okay. This is a website, and there are a whole bunch of different kinds of normal calculators that you can find online. Unfortunately, I can't show you this at the same time as I show you the problem, so you'll have to bear with me. We're looking for, you have three different ways of using this table. This tool, rather, which is equivalent to a table. Our table gives us two ways we can use it, but this gives us three. I'm interested in up to z, that's 67th percentile. I can drag this over until I get to 67. And indeed, what's my z-score? 0.44. That was the same thing we got when we did this manually, right? 0.44. Oops, I guess it disappeared. Okay. Or if you like, we can click 0 here. And again, we now look for 1.7. Again, you saw it, 0.44. All right. So if you prefer, you can try using this website. Let me copy the link for you, and let's put it into our video here. If you like, you can use this online tool to calculate these z-scores. You have to understand how to use it, though. You have to understand. I'll come back to this in a second so you can see it. Or you can actually just pause the video or go back in the video to see this again. But let me show you. You have to know what you're doing here. Just the way you have to know what you're doing with the tables, you have to know what you're doing with this thing here, with this calculator over here. If we're interested, as we were in that previous problem, in the tail of the distribution, then we're going to select this third button, Z onwards, and drag until we get to the z-score we calculated earlier, which was 1.25. So we drag until we get that score and read the corresponding area in the tail of the distribution. And that was the same thing, it was the same answer we got when we solved it by hand, when we used our static tables. We got that 10.56% scored greater than a z-score of 1.25, which corresponds to a raw score given in the problem of 190. What I would urge you to do, especially if you want to make real use of this online calculator, is I would urge you to try to solve these problems both ways. Try to solve them with the online calculator and try to solve them with the table as well. See which works better for you and take it from there. All right, I realize this has been a lengthy video and you may still have problems, but you all know how to reach me and we'll be going over this in class. You all know how to reach me if you have any questions and need some one-on-one help. Thanks so much, and I hope you found this helpful.